I'd like to thank JLC3DP for sponsoring this project. They provided the really nice resin print that's transparent and looks amazing. In addition to that, for the very large PCB, the white one that was used for the project through the sister site, JLC PCB. Now, JLC 3DP is very easy to use. You can go to their 3D printing, upload a 3D file here in STL, and then select what type of material and technology you want to use. In this case, I used the SLA resin and the 8001 resin of that, which comes in both transparent and translucent form. I used the transparent, which does additional sanding and oil spraying. It's really nice to the touch and allows you to see right through it. It's amazing, and I'd highly recommend using their services. I'd also like to thank the Superbox sponsors who helped put this contest together, which allowed me to build the other additional board with the help of the PCBWay coupon, and allowed me to use the ESP32S3 provided by Seed Studio. The other products from this list were great too. I tested them out and they were wonderful. Now let me continue on to discuss the mouse itself.
So as you can see, the mouse is moving, and it's doing this through my thumb being on the mouse rest. Now if I remove my thumb, it stops moving, and this allows it to stay within this region, but also be controlled. Next, I'll go over the different buttons. There is the left mouse click, to be held, and to drag and select things, as you can see on my screen. There is the right mouse button. There's the ability to increase sensitivity, decrease sensitivity. There is forward and back, which simply moves the cursor, or if you're in, let's say, Chrome, will go forward and back between pages. There is left click, right click, and in addition to those other buttons that I described, there is the ability to turn on and off the LED effects, which, as you can see, create a rainbow-like effect in perpetuity.
That sums up the functionality, so now I'm going to go into the build process. So I'm going to take this circuit board and use it for a PWM3360 mouse sensor. And the idea behind it is this is going to be a little board that I use for tons of different mouse projects that kind of fits into the larger boards. And I already have one set up for a current project I'm working on, so I'm hoping that this works and then I'll be able to move forward. I've gone ahead and soldered or placed all the components where possible using some solder paste, and I'm hoping my hot air gun is able to handle this fairly well. We shall see. I ahead and heated it up with the heat gun, and it looks pretty good. I'm going to test it in a moment to make sure that the pins are all not connected together. For example, on the linear regulator over here, voltage regulator. I'm not going to be connecting a connector here. I just have this in case I need it for the future. It was more of a if I wanted to have this like positioned all the way over here and then a wire going from there for the signals versus using these two headers that are going to push down upon the main board. I'll go ahead and solder the sensor. Actually, yeah, I think it might be a good test to run 3.3 volts through that line and see if it's able to properly give me the 1.9 volts from the output of the linear voltage regulator. So I guess I'll do that test first, and then after that I will solder in the sensor. I only have one of them, but it's located out here. I'll cut this in the video. Yeah, so I'll be using this sensor after. Wanted to confirm everything was properly hooked up, and I'm getting about 1.9 volts on the voltage regulator on here as intended on this pin. So it looks like everything's working perfectly. So now I'm going to just solder in the PWM3360 and hope for the best. that, I have everything complete now and soldered on, and it's ready. So I'm ready to try it out. I wish I had made the silk screen a little bit lower, as it kind of covers it with the casing on, but not the end of the world. I also wish I had done a better job with the labeling here. I started doing that where I put the ohms or the resistance and capacitance directly on the board so that I don't have to refer to the schematic as much when I'm putting it together, but this is fine for now. I unfortunately didn't take a video of this aspect, but I did connect it to a Xiao to confirm that it fully worked, and the board itself was wonderful and it was able to proceed from here. I also didn't take a video of this, but I'll describe it. I soldered on the components to the larger mouse board that the core board connected to. Unfortunately, as you can see there, I'm using the Xiao ESP32S3, which I later had to desolder and switch with an ESP32S3 because the C3 doesn't support HID for the mouse. So the design has multiple different layers that are stacked together to kind of create the board, and one of the issues that came up while I did that was I had intended to use conductive paint to allow the signal to go from the top to the bottom so it could be touched, but I found it to be way too I didn't have enough sensitivity. So what I ended up doing was use copper tape here, both on the board itself and then on the printed board, to allow the signal to still make it through. And what you're looking at is the original design here. Another issue I ran into was I had hoped to use magnets underneath the board to levitate the board, but I found that when the magnets were positioned perpendicularly, for some reason they weren't causing any lift, so it created more of a problem with the heaviness of the 3D print versus not, which was really nice looking, so I really regret it, but I ended up working out well with just the elastic. To discuss the remaining setup pieces, I had eye-hole rings around the outside of the board, and then attached elastic strings to the perimeter, allowing it to be stretched to kind of have a basic position in the center which you can spring back with. I found it worked really well, and it didn't have too much problem pushing it. I'd like to use rubber bands in the future though. So that's my mouse. Please like and subscribe for more content. Thank you for watching.